Okay, to calculate this mean and the variance, I believe it is easy. I believe you know how to calculate the mean. So the mean is $200. Also, it's easy. So you make $500 with 90% and 20 minus 2,500 with 10%. So calculate the weighted sum of the outcomes. And let's look at the variance. So variance is the sum of probability weighted squared deviations. So squared deviation is calculated as the outcome minus the mean, which is 200. So 500 minus 200 and minus 2,500 minus 200. So these are deviations, and you square them, square deviation, square, then probability weight, multiply the probability, and if you calculate these numbers and sum these two numbers, then you get 810,000 as the variance. So, and you have a calculator, so it's not that difficult. In chapter 4, we practiced how to calculate the variance using multiple columns. At that time, I showed you have to calculate the deviation first and then square them and then multiply probability and then sum them. But I did it at once, believing that you remember how you did at the time. So anyhow, variance is a large number, but I chose this number intentionally because when you take the square root, it equals to 900, which is more easy to handle. And so the mean is $200 and the standard deviation is $900. This is for a single insurance policy holder. So for each person, for each customer, the insurance company expects on average $200 profit, but there is a risk, huge risk, $900 risk. And then using the properties of the sampling distribution, we know the mean of the average. Now we consider the average. Expected value of the average is $200 because this is the same as single outcomes expected value, but the standard deviation of the average is different. It's 900 was the standard deviation of a single outcome, but you have to divide it by the square root of the sample size. And the sample size is 100 because the average is calculated from 100 policy holders. So the sample size should be 100. So that's the number of numbers used in calculating the average. So as a result, standard deviation is 90 after scaling back using the sample size. Then using the central limit theorem, we have a normal distribution with these two parameters, 290 squared. Because it's standard deviation, I used square there. And as you see, it's amazing. The central limit theorem is amazing because we started from this kind of distribution, but in the end, we don't need to know what distribution this is. What we need is just the mean and the standard deviation, and then normal distribution. That's how the central limit theorem works, and power of the central limit theorem, the CLT. Then from now on, it's exactly the same steps as we practiced in chapter 6. We wanted to calculate the probability that the average profit is negative, and we now know that X bar follows a normal distribution. So in the normal distribution chapter, we had to standardize the probability first. Standardization means subtracting the mean and dividing by the standard deviation. In this case, remember the random variable is x bar, so the mean is the mean of x bar, and denominator is the standard deviation of x bar. Of course, the standard deviation of x bar can be replaced by the ratio between the original standard deviation divided by square root of n. Anyhow, the principle is the standard deviation of the original the variable here. And also, we have to standardize the other side of the inequality. So plug in numbers. We have these two, and easy. The standardized random variable becomes a standard normal distribution, and this number is simply minus 2.2222. And from the standard normal distribution table or Excel or whatever program you are using, it is easy to calculate this CDF. It's a standard normal distribution CDF evaluated at this point. So plug in minus 2.22 into the program and into the calculator, and you get 1.313%. So this step is from chapter 6, and this step is from chapter 4. So from now on, like you need to like remind yourself of what we learned when you face this kind of past topics. But you can watch the videos again. That's nice. By the way, so let's interpret the result. This is amazing because previously, watch this, previously the probability of loss was 10%, and it was huge loss with 10%. But after you collect 100 independent customers, that risk is only 1%, 1.313%. So it's much more manageable. So the loss of the business is very unlikely, and you will be surprised if you increase the scale and see what happens there. Now, to see the power of the scale of economy, the economy of scale, excuse me. So then the risk will be even smaller. So now suppose that there are 10,000 policies sold by the company, and everything else is the same. Probability distribution is the same, and all these policyholders are independent across with each other. And just the only difference is the sample size. Then let's calculate the probability of loss when you have 10,000 customers. Try this. Calculate. Of course, you are going to you may utilize the numbers we calculated ahead previously, and you need a program. You need to open Excel to calculate this probability, and do it by yourself. And I'm going to continue in the next video. So see you in the next video. Thanks.